Welcome to clickmyproject.com. Let's discuss on the title Semi-Supervised Biased Maximum Margin Analysis for Interactive Image Retrieval. Two-class SVM is one of the popular small sample learning method widely used in recent years and obtains a state-of-art performance in classification for its good generalization ability. The SVM active learning method selects samples that are close to the boundary as most informative samples for the user to label. Random sampling techniques were applied to alleviate unstable, biased and overfitting problems in SVM RF. One problem stems from the fact that different semantic concepts live in different subspaces, and each image can live in many different subspaces, and it is the goal of RF scheme to figure out which one. However, it will be a burden for traditional SVM based RF scheme to tune the internal parameters to adapt the changes of the subspace. Such difficulties have severely degraded the effectiveness of the traditional SVM RF approaches for CBIR. Additionally, it is problematic to incorporate the information of unlabeled samples into traditional SVM based RF scheme for CBIR. Although unlabeled samples are very helpful in constructing the optimal classifier, elevating noise and enhancing the performance of the system. To explore solutions to these two aforementioned problems in the current technology, the paper proposes a biased maximum margin analysis and a semi-supervised BMMA for traditional SVM RF scheme based upon the graph embedding framework. The proposed scheme is mainly based upon the following, that is, the effectiveness of treating positive examples and negative examples unequally, the significance of the optimal subspace or feature subset in interactive CBIR, the success of graph embedding in characterizing intrinsic geometric properties of the dataset in high-dimensional space, the convenience of the graph embedding framework in constructing semi-supervised learning techniques. Let's enhance the paper by using multi-class SVM and provide a comparative analysis of the existing and the proposed system. Regarding the data flow diagram, this diagram consists of both the training stage and the testing stage. In the testing stage, you will be selecting a query image, you will be extracting the features, namely color, texture and edge features, and you will frame them as a test feature vector. So this particular test feature vector will be subjected to a trained multi-class SVM classifier. For training, you have to consider all the database images, extract the features for all the images in the dataset and align it as a trained feature vector as a matrix representing the rows as number of samples and columns as number of features, and train the multi-class SVM classifier. It will be predicting some image categories, and that image category should be again referred to database image for retrieval. Finally, you will be retrieving certain images and testing with the relevance feedback. The test image category will be predicted by this multi-class SVM and then subjected to the database images for retrieval. There also the retrieval image and relevance feedback mechanism will be tested. Now let's see the execution of the program. Regarding the execution of the program, you have to click main guy.m and press run file. This is the guide designed to view the results of the algorithm. First, the training has to be completed and the features will be extracted. For training, the samples will be displayed. These are the samples considered for training. The features are being extracted. Those features will be displayed in the table after completion of the images. And you have to do the database classification using multi-class SVM. Learning and testing will be done, and the below table shows how many classes are being correctly classified and how many classes are being incorrectly classified. As the database is large, it takes some time. These are the features. These are the extracted features. These are the images. Row represent the images and column represent features. Now database classification. So this is a graph symbolizing how many images are being correctly classified and how many are being misclassified. This number can be seen in this database classification table. There are totally 10 classes of classification labels. Now testing. You have to select an image and extract the feature. I'm selecting the image from the database. I'm selecting this image. You have to, and this is the feature extraction, Gabber feature. This is the histogram feature. This is test Gabber feature. This is color feature. And then you have to categorize it and retrieve. How many images are needed for retrieval will be asked in a dialog box. Defaultly it is being set as 10. Classification followed by retrieval will be taking place. It may take some time. The meantime, this is the classification accuracy 77%. This is sensitivity and specificity 80% and 85%. This is the classification end time, and certain images are being retrieved. This is the retrieval time. The retrieved images are like this. Now this is the graph showing the neighbor index and the neighbor distances. Next will be the precision and recall. You have to select a feedback query. I am selecting a feedback query as 2, and this feedback query, what is the retrieval number of images, this dialog box will be asking. Again I am giving as 10, and this is the retrieved sample, and this is neighbor index. Now that we had done an analysis without feedback. This is the recall graph, and this is the precision graph with feedback. This is the recall graph and the precision graph. Now on considering the analysis that are shown finally, we conclude that despite the promising results, several questions remains to be investigated in our future work. First, this approach involves a dense matrix eigen decomposition, which can be computationally expensive both in time and memory. Therefore, an effective technique for computation is required to alleviate the drawback. Second, the theoretical question need to be investigated regarding how the proposed scheme affects the generalization error of classification model. More specifically, we expect to get a better trade-off between integration of the distinct properties of feedback and the generalization error of the classifier. Thank you.